Good morning, everybody. Today we will discuss about the multiple regression models. So far we have learned about the two variable regression model or simple regression model, in which we have one dependent variable and one independent variable. This is known as a two variable regression model, simple regression model. In multiple regression model, there will be more than one independent variable. That type of regression models are known as the multiple regression model. For example, here yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. In this we have three variables. One is the dependent and two independent variables. In this we have more than one independent variable, and therefore it is known as a multiple regression model. Here, as usual, y is the dependent variable, x2, x3 are the explanatory variable or regressors, and u is the stochastic disturbance term, and I is the ith observation. And beta 1 is the intercept term, and it gives the mean or the average effect of y of all the variable excluded from the model. It is the average value of y when x2 and x3 are set equal to 0. And the coefficient beta 2 and beta 3 are called partial regression coefficient. This is very important. In a multiple regression model, these beta 2 and beta 3 are called as the partial regression model. We'll see the meaning of this partial regression model in the coming section. Therefore, in a multiple regression model, there will be more than one independent variable. All other things are the same, the interpretations, everything will be the same. And the interpretation of the slope terms like beta 2 and beta 3 are called the partial regression coefficient. This multiple regression model, like this two variable regression model, is also based on certain assumptions. That assumptions are given here. First one, the multiple regression model is linear in parameters. That is, the value of the regressors are fixed in repeated sampling. We have already seen what is the meaning of linearity, linear in variable and linear in parameters, etc. Here, in all the regression models, the most important assumption is that it is linear in parameters. That is, beta 1, beta 2, etc. should be linear. Second assumption is that zero mean value of ui. That is, in the two variable regression model, we learned that expected value of ui given x equal to 0. Here we have more than one independent variable, and therefore the assumption is expected value of ui given x2i, x3i equal to 0. This is the second assumption. And third one, no serial correlation. That is, no serial correlation or the covariance of ui uj equal to 0, where I not equal to j. This is the third assumption, covariance of ui uj equal to 0, or I not equal to j. And homoscedasticity is the third assumption, that is, variance of ui equal to sigma square. And the fifth assumption is zero covariance between ui and each xi variable, or covariance of ui x2, ui x3i equal to 0. That is, no covariance between the array term and the explanatory variables. There will be more than one explanatory variable, therefore covariance of ui comma x2i equal to 0, covariance of ui x3i equal to 0. This is the fifth assumption. Then no specification bias, that is, model should be correctly specified. Then another one, no exact collinearity between the x variable, or no exact linear relationship between x2 and x3. That is, no multicollinearity is the next important assumption. These are some of the important assumptions of multiple regression models. Multiple regression model can be specified as follows. The given y equal to beta 1 plus beta 2 x2i plus beta 3 x3 plus ui, the conditional expectation of y on both sides. See, conditional expected value of y given x2i x3i equal to beta 1 plus beta 2 x2i plus beta 3 x3i. That is conditional mean or the expected value of y conditional upon the given or the fixed value of x2i. This given as earlier. Here there will be more than one independent variable. The multiple regression analysis is the regression analysis conditioned upon the fixed value of the regression. That is, multiple regression analysis is the regression analysis conditional upon the fixed values of the regressors. This x2, x2i, x3i, etc. will be fixed, and it is the, or simply the multiple regression analysis is the regression analysis conditional upon the fixed value of the regressors. Here yi equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui, and the regression coefficient beta 2 and beta 3 are known as partial regression coefficient or partial slope coefficient. As we have already seen, this is the intercept, these are the slopes, and these are known as partial regression or the partial slope coefficient. What is the meaning of this partial regression coefficient? That is, beta 2 measures this beta 2 and beta 3. These are partial regression coefficients or a partial slope coefficient. Beta 2 measures the change in the mean value of y per unit change in the x2i. Beta 2 measures the change in mean value of dependent variable per unit change in x2i, holding this x3i as constant. If we keep this as constant, what is the effect of this variable on the average value of the dependent variable is the meaning of partial. We are keeping the other one as constant. Therefore, it shows the partial impact on the dependent variable. The total impact will be the impact of x2i, x3i, x4i. If then number of independent variables are more, then the total impact will be the impact of all these variables. If we take each and each coefficients, then it shows the partial one. Partial means the other things are kept as constant. Therefore, beta 3 measures the change in the mean value of y per unit change in x3i. That is why it gives the or the partial regression coefficient means it shows the direct or net effect of a unit change in these variable x2i or x3i or yi. Therefore, these terms in slope terms are termed as partial regression coefficient or partial slope coefficient.